Type 1 and Type 2 errors are important statistical concepts to understand when we're doing hypothesis testing. It's important to remember that whenever we make a decision, it's possible that the decision we're making is incorrect. We're making the best decision that we can with the available information that we have at the time. However, that could be an incorrect decision. So when we do a hypothesis test, there are 4 possible outcomes. We can either fail to reject the null and the null is true. We can reject the null and the null is true. We can fail to reject the null and the null is false. Reject the null and the null is false. This might seem a little overwhelming at first, but if you just stop and think about what we're doing when we make a statistical conclusion, we're either failing to reject the null or rejecting the null. And then with each of those, there's the possibility that the null was true or that the null was false. However, only 2 of these are actually the correct decision. If we fail to reject the null and the null is true, that's correct. And if we reject the null and the null is false, that is also correct. So the other 2 situations where we reject the null and the null is true, and where we fail to reject the null and the null is false, those are both incorrect decisions or errors in our decision making. I like this matrix to kind of try to explain the difference between type 1 and type 2 error. I'm going to explain it here and then a couple of different ways because it's a difficult concept for some people to get, and hopefully one of the ways that I explain it will finally kind of click and you'll be able to understand it a little bit better. But it is a little confusing concept at first, so if you're feeling confused right now, you're not alone. Just keep thinking about it and thinking through it different ways, and one of the ways will help it to click in your brain. So this is what we were just saying, just depicted in a matrix. So we have the reality of the situation, which we never really know in statistics because we're making our best guess with the available information. But in reality, either the null is true or the null is false. And then the decision that we're making is to either fail to reject the null or to reject the null. So here, if we fail to reject the null and the null is true, that's our correct decision. And if we reject the null and the null is false, that is another correct decision. Where we commit errors is when we reject the null when the null was actually true. This is called a type 1 error. And then when we fail to reject the null and the null is false, this is called a type 2 error. So a type 1 error occurs if the null hypothesis is rejected when it's actually true. A type 2 error occurs if the null hypothesis is not rejected when it is actually false. Another way to think of this would be a type 1 error is rejecting the null hypothesis when we shouldn't reject it. This might mean that our significance level was too tight or too narrow. If we set a more narrow significance level than 0.05, so if we set it at 0.01, well then we know that we're going to have a chance of rejecting the null hypothesis when it's actually true because we've set a more stringent level on that, the decision that we're going to make based on our p-value and comparing that to significance level. With type 2 error, we accept the null hypothesis when we should not. Now they say accept the null hypothesis here. I don't particularly like that phrasing. I prefer to say fail to reject the null hypothesis because we never really know the accurate state. We're making our best guess, and really we could get new information tomorrow or next week that would change our decision. So I prefer the phrase fail to reject the null hypothesis. But here we have a significance level that's lower than our p-value. This may indicate a problem. Maybe we set our significance level too high, but it could just be that we didn't have enough information to disprove the null hypothesis. With type 1 errors, this is the probability of rejecting the null hypothesis when it is true. We represent this by the Greek letter alpha, and this can range from 0 to 1. So conventionally, we're going to set this at 0.05. We can go between 0.01 and 0.05. 0.05 is what we use if we don't have a reason to do something different, but when we want to be more stringent with our decision making, more conservative, and really only conclude that the null hypothesis is not true and reject the null hypothesis, we want to be more sure we're making a correct decision, we would set a lower significance level here. Our type 2 error is the probability of failing to reject a null hypothesis when it is false. This is represented by the Greek letter beta, and this can range from 0 to 1. Alpha and beta are related, so as one goes up, the other goes down. This is why we can't just say we're just going to set a level where we have a low probability of committing a type 1 error and a low probability of committing a type 2 error. They're kind of like opposite sides of that same coin, so we can't really get them both to be small at the same time. We're balancing the risk of committing a type 1 error with the risk of committing a type 2 error. Okay, so coming back to that matrix we saw in the beginning, we have the reality of our situation, the null is true or the null is false, and we have our decision we're making, fail to reject or reject the null. So we have a correct decision when we fail to reject the null and the null is true. We have a correct decision when we reject the null and the null is false. However, we commit our type 1 error when we reject the null, but the null is actually true, and our type 2 error when we fail to reject the null and the null is false. So you can see here how those are kind of opposite sides of the same coin. These are all possibilities within the same decision matrix. We have 4 possible outcomes, so we can't just minimize both of them at the same time. We have to balance it. And hopefully we're landing in one of these boxes, making a correct decision. But every time we run a statistical test and make a decision, there is a chance that we're committing a type 1 or type 2 error. I like to think of this in terms of the criminal justice system. This helps some people to make sense of it. If it doesn't really help you, then think about it and forget about it, I guess. But it does help some people to think of it in these terms. So what error does our criminal justice system favor? Well, with our criminal justice system in the United States, what's our null hypothesis? Now, we could have debates about the criminal justice system and the fairness of that criminal justice system in the United States. But if we just look at our null hypothesis, it's that it's better for a guilty man to go free than an innocent man to be convicted. So we prefer not to have innocent people be convicted, even if that means that we know that some guilty people may not be convicted. So if we look at our matrix we were looking at earlier, but think of it in terms of the criminal justice system, we have the reality of the situation, which is a person is not guilty or guilty, and we have our verdict, which is not guilty or guilty. So our criminal justice system does not use the word innocent. When a person is not convicted, they're called not guilty. It doesn't necessarily mean that they were innocent. It means there wasn't enough evidence to say that they were guilty. So if a person is found not guilty and is actually not guilty, that's a correct decision. If a person is guilty and found guilty, that's a correct decision. However, we would commit a type 1 error if we find the person guilty and in reality they're not guilty. And we would commit a type 2 error if we find the person not guilty and they actually are guilty. So think about that again. What type of error does our criminal justice system favor? Okay, our criminal justice system favors a type 2 error because we would prefer for a guilty person to go free than for an innocent person to be convicted. So we've weighed that balance in our criminal justice system, and the way that it's set up with the level of evidence and reasonable doubt that's supposed to be required, we're doing that because we favor a type 2 error, which is having a guilty person go free rather than an innocent person being convicted. A concept that's related to type 1 and type 2 errors is the concept of power. Now, power in statistics is the probability of rejecting a null hypothesis if the null is false. So another way to say that is that power is the ability of the study to find a difference if the difference actually exists. It's calculated by taking 1 minus beta. And remember that beta is the probability of committing a type 2 error. Power is affected by 4 things. Our effect size that is demonstrated by the study. So the effect size is just how strong that difference is between the groups. Our sample size, our level of significance that was chosen. Again, typically this will be 0.05. And then our power, which is chosen, or our implied beta. So these are all mathematically derived. What that means is that if you know one of them, you can solve for the other 3. Taking this a step further, this means that using the parameters that we either know or that we can estimate, we can calculate our necessary sample size before we conduct a test. So we can take the effect size that we think we'll see, or that difference in the populations, our level of significance that we're choosing, which will typically be 0.05, and then the power that we want to have, which would be adequate power to find a difference. And using those 3 parameters, 1, 2, and 3, we can then calculate the sample size that we need in order to find a difference. A lot of times people will do power analysis as a post hoc test when they don't have significant results. So they conduct some sort of statistical test. It doesn't have any significant results. So then they go back and they do a power analysis and they say, oh, well, we didn't have significant results because we didn't have enough power to find a difference. So basically, no matter what they did in their study, they weren't going to be able to find a difference, even if that difference is there, because their study was underpowered. What we need to do instead is think through this before we conduct a study, so that we know that we have enough power to find a difference if it's there. And one of the main ways that we're going to increase our power is by increasing our sample size. The ability to find a significant difference is highly related to sample size. So the larger sample that we have, the better able we are to find a difference. This is especially true when we're looking for small differences or small changes in our population. Just want to give an example of power before we move on to do a summary. So I was working with a rural county that was doing a community health assessment, and they wanted to conduct 50 surveys with residents. I know that sounds really small, but this wasn't a large area like Phoenix or New York or Dallas. We're talking about a very rural county. But I did a power analysis and calculated that we would need to conduct 275 surveys in order to find any differences in the population. So I went to the people at the county and said, okay, we need to do 275 surveys or we're not going to be able to find any difference anyway. And that enabled them to change how they were doing the assessment a little bit before they started it. So the main takeaway message with power is that this is something you need to think through before you do a study and make sure that you have enough power and a large enough sample size to find a difference before you begin. You can make adjustments before you begin, but after you've already collected your data, you're really stuck with what you have. So I'm just going to summarize the concepts of type 1 and 2 error and power that we've been talking about. A type 1 error occurs if we reject the null hypothesis when it's actually true, and a type 2 error occurs if the null hypothesis is not rejected when it is actually false. So we fail to reject the null hypothesis, but it is actually false. Power is the ability of a study to find a difference if it actually exists, and this is something that we can and parentheses should and parentheses calculate before we conduct our study when we're in the study design phase. Alright, I hope this video helped you understand the concepts of type 1 and 2 error and power a little bit better and understand how those are important to hypothesis testing.